So how many different triangles can be formed given this information here? Well, we can reorient the side length of 8 since this angle is not fixed and this length of line is not fixed. The shape of this triangle is not fixed, and we can orient this length of 8 in this direction here like this. So there are two distinct triangles that can be formed. Okay, so we have that length there, and that triangle there, and we have also the big triangle here. Okay, so if we want to find the areas of these triangles, we need to be able to use the perpendicular height, okay, which I'm going to draw here, this perpendicular height here, and that line is going to be, I'm going to call that h over 9 is equal to sine of 55 degrees. Okay, so that means that the length h is equal to 9 times sine of 55. Okay, so that gives us a length h. H is equal to, so 9 times sine 55. We get 7.37. Okay, so it's important for the area of the triangle that we need to find the height of the triangle. We also need the length of the base. Okay, so I need to find out the length of this base here. I'm going to call B2, and I need to find out the length of the bigger base here, which I'm going to call B1. Okay, so to find this, then we need to solve these triangles. Okay, so first of all, angle side side, there's an ambiguous case. There's two possible triangles that can be drawn here. Okay, so I've kind of put them into one diagram. To find the area, we need to rely on the height and the base, so we have to solve this triangle to solve for the base. So I'm going to solve for the first one here. Okay, so we've been given angle and opposite side pairing. Okay, so that means sine law. So we want to solve for, in this case, I'm going to solve for first C1. Sorry, I'll call that B1. Okay, angle B1 is going to be based on sine of B1 over the opposite side 9 is equal to sine of 55 degrees over the opposite side of 8. And that's the one, that's the pairing, the known pairing that I have. So I'm going to solve for B1. Nine times sine 55 divided by 8 is going to give me 9.92. I'm going to round that to 2. So angle B1 works out to be, okay, so I need to use the arc sine of that, 67.15. And that works, so it's 67.15. 67.15 degrees. So it's going to write that in here. Okay, so that makes angle C1, when I solve for 180 minus 67.15 minus 55 degrees, I get 57.85 degrees. Okay, and then I solve for side C1 using my sine law again. So 57.85 degrees. And that's going to be, I'm going to use the known sine law ratio, the known angle and opposite side pairing, and I'm going to solve for C1. So C1 works out to be 8 times sine 57.85 divided by sine 55, and that gives me 8.27. Okay, so that's my C. This is, sorry, C. I should have mislabeled this. This is C, my C1, and this is going to be my B1. Okay, given this is my angle B. Sorry, that's going to be C1, C2. Okay, so this is angle C here, so that side's opposite. So this is B opposite side B. So that's my length of C1. So I'm going to be able to find the area of the black triangle using my height. So I'm going to call area 1 is going to be my 1/2, my width 8.27 times my height, which I calculated here. The height for both triangles is the same, 7.37. So again, with all this rounding, we're going to be off a little bit. My area is going to be 30.47. Okay, so the area of the black triangle works out to be 30.37 approximately. So 47 approximately. And that's going to be units squared. Okay, so this is going to be the area of the black triangle. To solve for the area of the red triangle, I need to solve for side C2. So then I need to solve for angle C2 here. So angle C2, I subtract from 180. 180 minus 55 degrees. Oh, I haven't solved for B1, B2. So angle B2 is a supplement of 67.15. So I do 180 minus 67.15. Okay, so this angle in here is going to be 112.85 degrees. Okay, and that's because it's supplementary to this angle in here, because that makes a right isosceles triangle with this other 67.15 degrees. So there's my angle. So finding C2, I subtract from 180. So I do 180 minus 112.85 minus the 55 degrees, and it's going to give me 12.15 degrees. Okay, and then using that 12.15 degrees, I'm going to find the length of C2. C2 over sine of 12.15 degrees is equal to, and this is a sine law again, I'm going to make it equal to my original angle side opposite pairing, so 8 over sine of 55 degrees. Okay, so I end up with the length of C2. When I cross multiply that, I get sine 12.15 times 8 divided by sine 55 degrees, and I get 2.06. So 2.06 is the length of C2. So then I can work out the area of the red triangle by using 1/2, 2.06, and then I have to use the height of that triangle, which we calculated at the very beginning, 7.37, and the area of the smaller triangle is going to be 7.59 units squared. Okay, so there is the area of the second triangle that can be formed. So again, we have to recognize that we have an angle side-side situation. That means that two triangles can be formed. So we have to be able to solve a problem like this, finding the area of this triangle, we have to essentially solve for two different triangles. Okay, the one added piece in here is because we're finding area, we have to find that vertical height. Okay, we can use that, drop that down, and we can just use right triangle trig here to find out the height of that triangle.